Hi guys, I wanna show my Starkey circuit and how it works and some things that I found. In my Starkey circuit, how you can see, this is the TL494. This is the TC4093VE for delay. That is the MOSFET driver, both MOSFET. And this is the MOSFET that I am using. This MOSFET is the 260, I think. I'm going to check it later. This is the snoover circuit. This is the coil. 1.5 millihenry is disconnected at this time. The diode. This is the MUR 160 are disconnected. This is the capacitor, 0.1 microfarad is disconnected at this moment. And this is my jack. I am using 12 turn in one side and 12 turn in another side. How you can see, the jack is split, but it's closed. This is where the jack is split at this point. I win in this side the 12 plus 12. At the other side, this is the 28 turn. I'm not using now. Is this disconnected? I'm not using now. This is the turn. The 3 turn are connected, and this way, this capacitor, and this way is going to the coil, to the granite coil. You can see in this way, here from here. This is my scope at the end of the jack. How you can see, this cable is ground. I'm not using now the ground. This is the cable come from the jack. It's going to the MOSFET. This is the channel 1, the center, and this is the disconnected. There's nowhere disconnected. This point is to channel 2. This point to channel 2 is going to my scope. How you can see, this is the signal that I looking at the MOSFET transformer. This is the drain. So I'm going to show you that I using 2 boards in serial. Those boards are 110 AC board and 100 watt. How you can see, my power supply is 24 volts, 2.71 amps. This is my voltmeter. At this time, I'm going to disconnect the board. What happened when I disconnect the board? You can see the voltage increase, the power supply current increase too, but the scope keep only the same. You can see a little change. I disconnect, the bulb is connected. At this, the bulb is disconnected. Now, what happened if I make a short circuit the output granate? What happened? Let me see. Let me show you. Here, absolutely, the board is extinguished. The ball is coming exactly how you can see. But the signal, the output signal at the scope is reduced a little. Only is reduced a little. Now, what would happen is I make a short circuit at the jog 28 turn short circuit? What happened? Look. Look. The ball dismiss, the output in the ball dismiss. In my scope, as a little up, you see what is different? Yeah? Short circuit, the 28 turn, open, the 28 turn, the output elevator, the short is going to 0. The power supply, when I short it, is a little high. Well, now I'm going to show you what happens when I move the duty cycle and I move the frequency. For example, let me go to the duty cycle. What happened to the form the way at the drain at the output, the MOSFET point? How you can see is less. How you can see it increase. If I make to increase this point more and more, the MOSFET maybe get hot. So I had to reduce this point to find the point where the MOSFET not get hot. How you can see the output voltage and my power supply current. Let me continue with the duty cycle. Duty cycle, more, less, duty cycle. Start to speak. A speaker. Now you can see that. Let me increase duty cycle. You can reduce duty cycle, reducing duty cycle. I am reducing duty cycle at this point. How you can see. Now let me show you what happened when I move delay for channel 1 and channel 2. This is one delay. How you can see it move a spike. You can reduce a spike. In one way, you can see how the spike coming up. So you reduce the spike using the delay. How you can see delay. Okay, this is in one channel. Let me show you what happened in the other channel. Here, this is the other channel. How you can see the spike is growing. What you use to reduce the spike using the delay. Spike the delay. Now you can see. So how you can see at that frequency the bulb is not maximum illuminated. It means that the circuit is not in resonance absolutely. I'm going to change the frequency control to see what happens when I find the resonance. resonance at this pin. Look at this. When you find resonance, more or less here, some spikes are coming. How to eliminate those sparking? I'm going to use the duty cycle. The duty cycle, using the duty cycle. Oh, wrong way. Duty cycle. Duty cycle, how you can see, to eliminate a spike. But what about the MOSFET? Don't get hot at all. Absolutely nothing. Nothing, absolutely. Not get hot. Even for a long time. Well, I want to show you what happens when you connect the snoozer. Let me show you. When you connect a snoozer, this is the filter. I'm going to do it only in one side. The capacitor for the snoozer is connected. Now I'm going to connect the coil. How you can see in my scope, only in one side is reducing the ringing. This thing happens if I connect the snoozer in the other side. Let me clear a little that. Now I am connected the snoozer. The snoozer is connected at this point. I'm going to disconnect the snoozer. Disconnect the snoozer, the coil, and the capacitor is disconnected. How you can see, I can get different, better way at this point. Is my starter circuit. Everything is cool. Nothing is hot. Let me show you everything. Well, now I'm going to connect another type of bulb. Let me disconnect this one. Disconnect. This bulb is 110 volt, 2000 watt. At this point, when nothing is connected, you can see what is happening in the end of the jug. Now I'm going to connect the other board, the first board. It's connecting. Disconnecting. Connecting the other one. It's a little light, but the shape of the ringing is almost the same. Nothing changes. The power supply, 24 volt, 2.29 amps. The voltage output is here, how you can see. And the MOSFET not get hot. Nothing, absolutely nothing get hot. How you can see, absolutely nothing hot. Wow, nothing. This point is a little, but not get hot at all. Another things I want to show you is the capacitor that I'm using. How you can see, this capacitor is 0.47 microfarad 2000 volts. This capacitor is I can see CBB81. CBB81 is this capacitor. So the grenade, this decoy, this is decoy for the grenade. Look at the grenade. Decoy output here. Only with three turn. What can I say to you? That is crazy. Well, might not crazy, but it's working absolutely cool. Muffet, not get hot even for a long time. Snoover are not connected. At one point, when I tell you that I think that is very important, is this capacitor. This capacitor is connected to the top center of the job, and this capacitor is 50,000 microfarad. This capacitor, I think that this capacitor is very important to be connected. I think that this capacitor eliminate the spike. Well, if you wanna go to know anything else about that circuit, please let me know. I'm going to show you everything that I have discovered using this interesting circuit. This is the Stalker circuit, how you can see here. This is the Stalker circuit. I'm using this one, this point. This is a delay that I am using, delay, and the driver. The driver that I'm using is this one. This MOSFET, I'm using the MOSFET. I don't using diode here, no diode here, only capacitor at this point. Well, guys, I have not implemented this circuit yet. I think that a cooler for this, in this case, could be better, but this is another topic. This is another thing that I'm going to show you later. Hey guys, let me see again. MOSFET, nothing, absolutely nothing. It's cool, nothing got hot. How you can see the shape, you can see the shape. Now I'm going to show you the gate, the MOSFET gate, here at this point, the MOSFET gate. I'm going to show you the MOSFET gate. How you can see the MOSFET gate. That is the MOSFET gate. You put together? Look at the heavy duty. The duty cycle. I'm sorry for my English. Look. This is at the gain of the MOSFET. How you can see? This is at the gain of the MOSFET. Look. Interesting things. You can see it? Interesting. This is the gate. This is the gain. The gate of MOSFET gate. You can see? What other thing I can show you? If you wanted to know more about my circuit, please let me know. This is the bulb. Another interesting thing, I'm going to connect another bulb. This bulb is the oven bulb. The oven bulb. I'm going to connect at this. I'm going to remove the 200 watt. Oh, you can see, this is the microwave bulb. You can see, my meter has been disconnected. This is the voltage for my meter. This is the voltage for the power supply. You can see, the shape doesn't change. I'm going to show you what happened in the MOSFET. With MOSFET. You can see, almost is the same. Nothing changed. But when you get a high spike like this, try to control it, that it would not be wide at this point. If you get short nanosecond at this point, short should be better. If it make wide at this point, you get the MOSFET hot. But how you can see, MOSFET not hot at all, not hot, absolutely nothing. A little, but very little. Absolutely, I can say it's so little that I can say absolutely nothing. Nothing get hot. Nothing get hot. Well, guys, see you next. You have a question, please let me know. I'm going to tell you everything that I find in this interesting stalker sequence. Bye. See you next.